let's take a moment and actually derive an analytic solution for the position of a particle in a constant force. And you're going to see something familiar at the end, I think, if you've taken physics before. If you haven't, it's okay. Don't worry about it. So let's start off with what we know. I'm going to say the things that we know. So what we're going to find is an analytic solution. Analytic just means that I'm going to have R now as a function of t. It's going to have a functional form. It's going to be something where no matter what t is, I can plug in 30 seconds and get exactly what R is. So it'll be some function of t. Okay? So I plug t into my function, which will be on the right-hand side of the equation, and I immediately get what the value is, and this has to be a vector. The function will be this, and maybe I should make this a fancy f to disguise it from force. And I'll put a hat on it. There's a fancy function f. Okay, so fancy function f. That's what we want in the end. We want something related to something that's just continuous. So let's do it. I'm going to work in 1D, p of x, and in fact, I'm going to work so in 1D that I'm going to just remove all subscripts that might be confusing. So this is all scalar functions. We're not talking about vectors right now, and it's true for all components. So this I'm just going to work in the x direction. Okay, so p final equals p initial plus, well, f net, and this is again in the x direction, delta t. And because I want t to be a continuous function, I'm no longer going to work with deltas. I'm going to erase that delta and just put t here. F net times t. Because I want a solution that doesn't have to worry about iteration. I don't want there to be iterative pieces. Okay. So now what I can do is I can go in and I can solve for the velocity. V final equals V initial plus F net t over m. I just divided out my m's to get me velocities. Okay. Now all I want to do is say that I now know V final, and because I'm going to work in a constant force, remember, constant force said I can choose V average to be V initial plus V final over 2. It's the arithmetic average velocity. So V average is just equal to, well, V initial plus V final. And V final is defined here. This is V final, all of this, right? This is an equal sign. So I'm going to say that V initial plus, well, V initial plus F net times t over m divided by 2. That's the value of the average velocity. Okay, so I have an important component. Now, I don't want you to get confused by this. I'm just using definitions of what V final is, and I still don't know what V initial is. I'm going to work completely with all things symbolic. Okay? So V average then becomes well, I get 2 VIs plus 1/2 times, well, just this. V, and so this is just F net this has, I'll just make this, I'm sorry. This is F net over M. Okay. I want to drop any M's. So the V average is now V initial plus 1/2 F net over M times T. That's an analytical solution for the average velocity. Okay. Well, let's go back. I'm going to put this in a special place. So I'm going to erase all my derivation to get to here. I started with the momentum principle, and I ended up with a special thing. V average is equal to V initial plus 1/2 F net divided by M times T. So I've rewritten it over here, so I'll erase it over here. I'm going to put this in a box because it's important. And now I'm going to solve for the position as a function of time, right? This is what we want. We want R, this is again in the x direction, R final is equal to R initial plus V average times T. Okay, well let's plug in. Let's plug in our value of V average. R final is equal to R initial plus, well, we've got a T, so we've got to keep track of our T. V initial times T, so every term picks up a T, plus 1/2 F net, well, I need to put that over an M, so I just got to go upstairs, F net over M times, well now, T squared. Okay. So, that's pretty cool. I'm just going to rewrite it here, getting rid of some of the brackets, equals R initial plus V initial times T plus 1/2 F net over M times T squared. Now, if you've taken physics in high school, you may remember this form from starting with kinematics. I'm also going to rewrite the velocities. So let's rewrite the velocities. V final is equal to V initial plus F net over M times T. Well, that's pretty easy. We have just gone from the momentum principle to the analytical solution for R as a function of time. We've just gone for the value of the velocity at every point in time just by dividing by m in the momentum principle. Now, I don't know if you've seen physics before, you may recognize this. What is a t squared? Well, it's a parabola in time. If I look at the position of a ball that happens to be in a force that's being forced downward in a negative direction, if I kick a ball, it's going to undergo a parabolic trajectory in time. That should look a lot like how a soccer ball is kicked. And if you're paying attention and you remember back to your old physics, remember this? F equals mg? Well, if I take this and divide by m, if it's just gravity, if it's a constant force, which is our source of constant forces, the Earth is a good source of a constant force, and that constant force is gravity, then this looks very familiar, I think. R is equal to R initial, and if it doesn't look familiar, don't worry about it. This tells you that gravity is our acceleration. We multiply the acceleration by time squared. We multiply our initial velocity times time. We have the initial position. We have the final position. So if I know something about how fast I'm going, where I started, and what the force is, I can tell you for all time what the position is. Similarly, if I know what my force is, and I know my initial velocity, I can tell you the velocity for all time, which is pretty nice. So I can replace these finals with t's. At any point in time, because that was a specific point in time, for any point in time, I now have a function that tells me everything I need to know.